Hi, welcome to StatStuff. I'm Matt Hansen. In this lesson, I'll introduce you to the transfer function and how it's a very critical concept in the DMAIC methodology. It's important that you understand the IPO flow model before beginning this lesson. So if you haven't already done so, I recommend that you view the Introduction to Lean and Six Sigma lesson that covers it. For now, let's begin with defining the transfer function. Well, before we formally define what a transfer function is, let's first ask, why do we even need to do data analysis? Well, let's remember that the goal of Lean Six Sigma is that we want to improve a process's, first of all, the effectiveness, that is, improving the quality or accuracy of the outputs that are coming out of that process, and also we want to improve the process's efficiency. Remember, that's improving the time, effort, or cost that's involved within the process itself. Well, in order to do that, to make those kinds of improvements, then we got to understand what changes will actually improve that process in the way that we want. And before we can do that, we have to first understand what controls the actual process. Now, the control of the process is what we express through the transfer function that we try to build as we do data analysis. Alright, so now what is that transfer function? This is how we might formally define it. It's y equals f of x, or we might say y is a function of x, or y is a result of a function of multiple x's, x1, x2, and x3, and so on. So we depict it as y equals f of x, and again describe it as the output response y is a function of one or more input x's. So it applies that an equation of the IPO flow model can be described in this relationship between various independent factors, what we're calling x's, and how those factors influence a dependent output response, or what we're calling y. Alright, that sounds a bit technical, but let's break that down into more simple terms. If you recall, we talked about the IPO flow model where we had input flowing into some sort of machine that creates some sort of process to finally create some sort of output from it. Well, we might translate that again as input, process, output, the IPO flow model. Well, if you notice from this, we would say the input is what we're referring to as the x's in the equation, and then the process is the function that's applied to those x's, and then finally the output, or that y, becomes the y in this transfer function. So it's the IPO flow model basically that we're adapting to what we're calling the transfer function, now calling it y equals f of x. Okay, so the transfer function is an equation of the IPO flow model. So why is it so important? I called it a very critical concept to the DMAIC methodology. Why is this transfer function so important to this process? Well, the transfer function again is like a control panel for a process. The more you can understand the different controls, the levers, the input dials, and all those things that are like on a control panel, the more you can understand how those influence the output results, then the more you can control and improve the output to a desired level. So let's apply a couple examples from that. Let's say we're talking about the picture settings for a TV, a television display, at least for an old school type of TV. The transfer function for something like that might be TV display is some sort of output that's the result of a function of, let's say, 3 different picture settings: color, brightness, and tint. These are usually the old school type of picture settings that are on TV. Well, each of these settings, color, brightness, and tint, are like independent variables. When you adjust the color level, you're adjusting only one thing that has no effect on the brightness or tint. But by adjusting just the color level, it has ultimately some sort of effect on the TV display. And as you make certain tweaks and changes to each of these different x's, each of these input variables, then those are going to have some sort of impact or influence on the overall TV display. So again, it's just a matter of defining what it is we want to control, like the TV display. We want to get it to a desired state of what appeals to us. Well, in order to do that, we have to then understand what are the variables that affect that TV display. In this example, they are color, brightness, and tint. So breaking it down to a transfer function, or this type of IPO equation, it would look like TV display, as my y, is equal to a function of color, brightness, and tint, which are my input x's. So let's try another example. Let's say you've got a stereo equalizer. Well, the transfer function for something like that might look like the sound quality, the desired quality of sound that I want to hear from my stereo would be some sort of function of, let's say, 3 basic types of audio settings: bass, mid, and treble. Again, these are independent of each other. I should be able to independently adjust just the bass or just the mid or just the treble, and as a result those will independently influence the sound quality. Or I can make multiple adjustments to all these different variables, and again they'll have some effect on the overall sound quality. Well, in this way, again, as I apply it as a transfer function, or like what I'm calling the IPO equation, it would look like the output Y, what I care about the most, what I desire is the sound quality. That's the result of some function applied to the bass variable, the mid variable, or the treble variable, each of those independent input factors. Now, the transfer function, we actually build one, can also include some sort of coefficients. And a coefficient is like a multiplier that's applied to a factor. So, for example, if we had an equation that looks something like this here in red, 250 equals 4a plus 2b plus 10. Well, the coefficients in this particular example would be the 4 and also the 2. These are the values that are in front of the variables a and the variable b. Now, using this example, we might say that A is probably a bigger factor in this overall equation. It makes twice as much impact compared to B because it has a 4 multiplying it. So since 4 is twice as big as the 2, the coefficient for this other variable, then we might say that whatever the variable is for A, that probably has twice as much effect on this overall equation in this overall output. Well, that's generally how coefficients work. And so when we build a transfer function using equations that are part of the data analysis, they might also have these kinds of coefficients where you might have one factor that has a bigger influence on the overall output than another one. Now, the transfer function itself is a really critical step or a pivotal step within the Six Sigma DMAIC methodology. The idea here is that once you build the transfer function, then again you understand what really controls the output. And once you understand what controls that output, now you can identify and fix whatever those root causes are that you identified in not meeting your desired output. Now that you know what controls it, you can adjust those inputs so you can meet that desired output. Now let's walk through another example of that. Let's just say that you have some issues where you're seeing your monthly fuel expenses going up in your vehicle. Well, we might want to build a transfer function for that. So the transfer function might look something like this. We've got fuel expense, which is the overall thing that we care about and that we're measuring, and that's the result of some function, some combination or process that's applied to all these different variables, like the fuel price, that is the price at the pump, the engine size, the vehicle weight, driving speed, driving habits, tire inflation, and many other variables that could be affecting the overall fuel expense that we're incurring. Well, based off of this, if this is kind of an example of a transfer function for us, then we might ask a few questions. Which of these factors has the greatest influence on fuel expense? Which one would we expect to have the largest coefficient? Well, probably fuel price, because we're seeing that the fuel price could have a huge influence on the overall fuel expense, because when the fuel price happens to go up just a $1 US or $2 US than it had been in previous years, it can have a huge effect on the overall fuel expense compared to some of these other variables. Now, which of these factors might have the least amount of influence on fuel expense? Well, again, the one that might have the smallest coefficient, that could maybe be some of these on the far right-hand side, or driving habits, or our tire inflation. If we don't have the right amount of PSI in our vehicles, then it might make a difference on our fuel efficiency, but does it make that big of a difference? Maybe not compared to fuel price. So using this example, obviously some of these variables will have a much greater impact on the overall fuel expense, our overall output Y, compared to some of the other variables. Now, which of these factors do you think you can control, and how much control do you think you have over them? Well, for fuel price, we probably don't have much control over that at all. At least not individually. I can control to reduce the price at the pump. It's usually already set for me, so I don't have a whole lot of influence over that myself. I can influence maybe where I do my purchase if I go to one particular gas station or another, or if I happen to be near a state line where there's some big differences across the taxes that are applied for gas in different states. Well, then I might choose to again buy my gas at a particular location or within a particular state. If I know I'm going to be around that location to make my gas purchase, I might wait until I go to that destination that tends to have lower fuel prices. I might control it in that way, but overall I don't have a whole lot of control for the fuel price. But I do have more direct control over some of the other things like driving speed, or maybe my habits, where I can plan for where I'm going to be driving. If I have to do a bunch of errands and within one day, I might plan for my route, so my route allows me to take more right turns and keeping me in a particular loop so I'm not waiting at a traffic light too long, or that it helps me not backtrack in different ways in my path that I'm taking for running my errands, if that's possible. I could also control the tire inflation, so I can control some of these other variables more than some of these other variables. Now, if there's one factor that changes significantly, how would that affect maybe some of the other factors? That is, what interdependencies might there be within these different factors? For example, one that stands out to me is engine size and vehicle weight. Well, the bigger the engine size, then that's going to have a direct impact on the overall vehicle weight. If I reduce my engine size, it's going to have some impact on reducing the vehicle weight as well. So there's some interdependency between these two variables, and that can very often be the case when we're evaluating a transfer function within the business. We might see several factors that affect the desired output that we're looking for, but as you adjust one, it might have some influence or dependency on maybe another factor. And it may not be to a one-to-one relationship, but maybe as I adjust one, it has some minimal impact on another one as well. So as we do our analysis, that's one of the things that we look for as well. We're looking for those interdependencies, and as long as we can identify them and understand the influence they have on one another, it can give us a better idea of how much we can control that overall output that we're trying to get to a desired level.
Alright, before we close this lesson, let's discuss how we can apply some of these concepts in a practical way.
Well, what I would challenge you with is to identify at least 3 top metrics that are used by your organization and ask yourself the following questions. First of all, what are all the potential factors? Again, those things that are input variables, or what we're calling X's within our transfer function equation. What are those potential factors that you think are influencing the metric? And then which of those factors do you think have the greatest influence on that metric? That is, the ones that might have the largest coefficient. And then which of those factors do you think might have the least amount of influence on the metric? Again, those might have the lowest coefficient. And then which of those factors do you think you can control? And how much control do you think you have over each of those? Now, if one of those factors happens to change significantly, are there any interdependencies that you see where it's also affecting another factor, if at all?
Well, that wraps up this lesson. Check out StatStuff.com for many more resources that can help you achieve powerful results. I'm Matt Hansen. Thanks for watching.